Hello, everybody. It's 7:41 p.m. Central Time on the 24th of May, 2023. It's Wednesday here in the United States, going into Thursday internationally, and we are here to talk about seismic events. In case you don't know where you're at, you're on the Earthquake 3D live stream. At least that's where this is being recorded. Let's go ahead and turn on a display capture, and maybe if I can get this darn thing centered on the screen, we can see it. There we go. Now what we're going to do is look at the earthquakes, but before we look at the earthquakes, I do have an update for everybody. We have fires which have broken out all the way up from Mexico down to the south, following the mountains up to the north, going across over into New Mexico, across Arizona, up into Oregon, and of course all the fires up to the north, up north of the border, up in Alberta, Saskatchewan, where all the smoke that you see here on the screen, all of this is smoke going down to the Gulf and back up to Canada. And of course these are storms. The white is the storms, but all the milky color that's over the Midwest, that is all smoke coming from up in Canada. Look at over on the East Coast. Again, all this in here is all smoke. Okay. You can tell the difference between where the smoke is and where it's somewhat clear, but now there's new fires breaking out where it's clear, and I'm going to zoom in on these areas to show them to you so you can see them a little bit better. Here's New Mexico. Here's Arizona. Look at the spacing on this. This is along the deformed edge of the North American craton. Look at the smoke starting to puff off there, and the fire starting to pile up next to each other. Well, when I say next to each other, it's hundreds and hundreds of miles apart, but still. Okay, so this is Arizona, New Mexico. We go down to the south. We're going to go down to New Mexico itself. And going all the way down through here, it's a little hard to see. Then we still have Popocatépetl volcano putting off big blasts. But just a lot of smoke down to the south, down in Mexico. Again, going over into the Gulf. It's kind of merging over into the Gulf of Mexico and going up through. Now, I haven't really looked up to the northwest yet to see if there's anything going on up to the northwest or in California. So at this point, I need to check each leg along the west coast from south to north and see if there's anything going on. So the way we do this is we literally just check to see for smoke plumes coming off the ground. And to give you a size perspective, a 5-acre fire next to my house didn't show up smoke-wise or heat-wise on the satellite that we're looking at here, GOES 16 and 17. So 5 acres didn't show up, so it has to be bigger than 5 acres to show up on this thing, visibly or with a black dot. All right, now let's go up to the north, go look up in California's northern section and see what's going on up here, if there's anything significant going on up here. We've got clouds, of course. Expect that. I don't see any big smoke plumes from any fires across California. So Arizona, New Mexico, we're not going to be able to make out much below the cloud cover here in Nevada. Well, before I say that, maybe we should go check. Let's go to sub-regional sectors across Nevada and just see if we see anything. Yeah, I mean, the cloud cover is not going to really allow us to see any potential fires or smoke down below that. Now, we get up to the north, and you should be able to see up in Oregon, and I don't know if these are quote-unquote control burns or if they're legit wildfires, but like I told you, we don't see smoke greater, again, 5 acres didn't show up next to my house, and it was really big. Let's go up into Oregon itself. So we have at least 2 spots here in Oregon, plus the 3 spots down across New Mexico and Arizona. That's 5 different fires going now across the United States, plus Mexico. And let's go up to the north and look at Washington. See if there's anything going on in Washington. I don't see anything really going on here smoke-wise. That's good. So it seems to be isolated down in Oregon, Arizona, New Mexico, Mexico. Let's go over to the east really quick and take a look at Montana. Are we going to be able to even see anything? Yeah, look at all the smoke over to the east. That's insane. And then the storm's blowing up out of that. The particulate matter on that's going to capture as much moisture as possible. If there's any moisture introduced into that smoke matter, you're going to get big outbreaks of storms. All right. And the reason that is the moisture, the water molecules go and collect onto dust particles and smoke particles in the atmosphere. That's how cloud condensation nuclei work. That's how rain forms. Let's go up to the north and take a look at Canada. So huge low pressure system came over the area last night and put a bunch of rain in the area, which is good for trying to maybe quell some of those fires up here in BC and Alberta. But over here to the east in Saskatchewan, I think it's still ongoing. Down through the clouds, you can see little black dots, but the black dots are, when I say little, that's going to be hundreds of acres. And smoke-wise, it's way less than what there was, but, I mean, obviously there's still a bunch there. Again, the smoke is this milky color that comes in below the cloud, the white cloud cover. You can also see it up here. It's a little brownish up on the north side. Again, that brown-gray smoke coming in from the north. So I guess there's some fires up north that we can't see up in. Well, where is that? Hold on. That's coming from up to the north of there. Okay, hold on. Just discolored clouds? Where's that coming from? Where is that coming from? Let's take it back 200 images and see. Wow, okay, so that's actually smoke that's been drawn up from the south, and then overnight, there's last night. Here we are this morning, and it's coming back down from the north. And I'm talking about this discolored area right here that's dark compared to the... So that smoke that was from yesterday that went up to the north and now has been pulled back down to the south in a big blob of smoke, if you will. Let's go across the Midwest and just look at it one more time. As the sun sets, you can really start to see it. And the storms that are forming along there are pretty intense. Along the barrier between, well, I mean, it's also the Continental Divide, but our southern flow coming in from the south mixing with that's pretty intense. Okay, so what's the deal with all this? Guys, look, there's something going on. Obviously, there's something going on with the fires along the edge of the plate in certain areas when the plate starts shifting. That's what's going on. It's obvious now. So we got a rare earthquake over here in New Mexico, and now we have a fire that broke out over here in western New Mexico. Just as one example, over here in Arizona, we got that seismic activity last week. Now today, we have fires equally spaced out across a big distance. So you could maybe tell me they're control burns, but are they going to do control burns on high wind days where it's dry? I don't know. Maybe. Okay, so that's what's going on with the fires, and I'm worried about it being related to plate shifting, which is why I'm taking so much time to focus on this. I wouldn't be focusing on any of this if I hadn't mentioned the fires last month. Now, you can't just tell me that it's fire season, because it's not fire season up north. Okay, just so we know that we get that clear. But we've seen this happen at all times of year. So before anybody tries to think that the fires are related to maybe heat or just, a dry area or whatever, well, the dry area is going to play into it for certain, but we've seen this happen all times of year, whether there's heavy rain in the spring or if it's in the middle of the winter. And when the plate starts to shift, these fires break out along the edge of the cratons, plural cratons, the plates. If there's things there to burn, they tend to burn. Now, what's causing the burning, I don't know, other than possible heat coming up. Other than heat, what else could cause it? There could be the potential of rock slides, of shale and flint, that would cause sparking that could cause fires, I suppose. That's also possible, like rock slides that cause sparks that ignite dry areas. I guess that's possible too. Okay. What else is going on? On top of the fires, obviously that's a huge, huge thing, but how about a spread of the same sized earthquakes over the last 2 to 3 days? And what size are we talking about? 6.1, 6.1, and another 6.1 that was upgraded to 6.2 within a few minutes of its striking. So it was 6.1, 6.1, 6.1 across the north side of the Indo-Australian plate boundary. Let me show you where we're talking about here. So basically, the north side of the Indo-Australian plate from Indonesia all the way over to Fiji, that's 5,000 miles or so, 4 to 5,000 miles. 6.1, 6.1, 6.1 across it, this section. Why? Well, back over here to the east, on the east side, a bunch of deep earthquake activity has taken place on top of large earthquake activity that goes back to the start of this week. So you see, really, the first 6.1 is an aftershock. Right? I mean, it's back at the 7.7 or 7.8? 7.7 location. The 6.1 struck first. So, really, that's an aftershock. And I would call it an aftershock if it's at the location itself and it's not moved. But then, within a day, we start moving to the west. Why? That's the way the wave comes up and goes out and away from the deep earthquakes. That's why we have the arrows there pointing over to the west, telling you which way to watch. So next, that struck. 6.1 spread out. A wave equal to 6.1 started to spread out over to the west. The wave size, 6.1, carried on over to the west and struck at the S-shaped plate boundary here where Indonesia is. And let me take you back over to the USGS page here. So we went from all the way over here at Fiji, came up from down below, dropping off 6.1s across the way over to Indonesia. Now we're going to see a spread go over across western Indonesia and up to the north towards Japan. Now, a new 4.5 struck in Japan in the past few minutes, but I'm just going to say it now. We are way beyond the warned time for Japan to get hit. I am canceling the warning for Tokyo completely. We are shifting the area to Alaska, and I'll explain why. Japan moved over the past 2 weeks with some semi-significant earthquake activity, going up into the near 6 range. Well, 6.0 plus on land in central Japan, 5 to the south, 5 to the north. We've progressed, a series of earthquakes has progressed up towards Kamchatka, but nothing significant has struck in Alaska itself. Now, we're going to see a compensation earthquake that's big, most likely in the upper 7 range, somewhere in that range. Now, I'm canceling the warning for Japan. That's the only spot I'm canceling the warning for. We still have a warning going for an upper 6 to strike in Sumatra. I still have a warning for an upper 6 to low 7 to strike in South Mexico. I still have a warning for an upper 6 to strike right down here in the middle of where all 3 sets of rings overlap down at Chile. We're not canceling those 3 warnings at all. We're waiting for those to hit, and all the signs are there that something's getting ready to happen in those locations. So, for instance, Mexico. Popocatépetl started to blow its roof off, whatever you want to call it, but it blew its top, making news down in Mexico, which is a big deal for a volcano in general in Mexico. And 30,000, 37,000 foot high blast, sending volcanic ash warnings out into the central Gulf of Mexico. That started. Then the fires started going all the way up across Mexico to the north. Now, on the north side up here, right here where all the rings are overlapping in New Mexico and Arizona, that's where our fires have just broken out in the United States. So I have a warning going in Mexico because a big, deep earthquake struck below Mexico. And I had a warning going in Japan because big, deep earthquake activity took place 2 weeks ago below Japan. That was all followed up by what happened in Japan over the past 2 weeks. So central Japan got that big earthquake. We got the swarm down to the south, a 6, and swarm down at Okinawa. And now we're going to look for a new 7 greater, possibly up to 7.8, 7.9, upper 7, to strike in the Alaska and Aleutian Island chain in the next 7 to 10 days. So we're canceling Japan completely. We're shifting the area over to the east. And the reason being is Japan has shifted. So the next spot to shift that has not shifted, all the other spots moving, Alaska. Central Alaska, in the middle of the whole hot mess. I hope I'm wrong. I hope it's just like Japan. So, in other words, I hope a break happens in the middle that's significant, but it strikes not on land, out in the ocean, nobody gets affected. That's what I hope for. And then a spread going out in each direction, and we bypass the 7. So right now, we are within the magnitude of what we're looking for. I mean, if I'm looking for an upper 6 to hit and we get a 6.3, okay, that's 0.6 off. We are within the magnitude of what we're looking for already, spreading out. I mean, again, we're at 6 levels spreading out, so that's where we are. Now, going over opposite direction, look, we got a 5.5. Check it off the list here. X marks the spot, Point Nemo. And we'll trace Point Nemo back all the way up here, goes right back into the fracture zone, the fracture zone, goes into the plate boundary, which that's where all our activity is spreading out from. So it's going out down to our letter X there, and it's spread across following our arrow. And where the arrow points, look at what struck in the past few days. I mean, it's just one after the other, after the other, after the other, piling up on top of each other. Now, in the middle, I'm expecting a break, up to 6.9, low 7, but probably an upper 6. Right here, where all the rings overlap. Most famous earthquake zone on the planet, I think. It's where the biggest earthquake in recorded history ever struck, so. That was a 9.5 in 1960. What else is happening? Central America. Look at what you guys have got going on from Mexico to the south, all the way into South America, and over to the east into the Caribbean. Make note of the magnitudes. 4.6 on one side, 4.6 all the way over on the other. In between, swarms and other 4.5s and 4.6s. Which, by the way, they downgraded 1 to 4.4, but. So we're going to see a break in the Caribbean that's at least going into the upper 5 range. We're going to take it a magnitude higher. If you take all of these 4s and add them together, it equals something like a mid-range 5. And if you take all the 4s plus all the smaller earthquakes, now we're going up a little bit more. And then add in Popocatépetl. Why were we adding in Popocatépetl? Well, if you're a new viewer, you have no clue what I'm talking about. The volcano here is called Popocatépetl in Mexico. It's been putting off the big blasts that have gone out into Gulf of Mexico. Each one of those blasts, I've said in the past, each large blast of a volcano equals about a 5, magnitude-wise, with the thousands of small earthquakes associated with it. If you were to add them all up, just roughly speaking, just a 5. And I put that number on there because after big blasts, we tend to see 5.0 range earthquakes strike right next to the volcano that blasted within a few days. And the reason I think that is it happened, well, I don't think that's happened. We've seen that happen. The reason I think it's happening, though, is the magma chamber shifts next to the red line. The red line is the plate boundary. So the magma chamber either inflates or deflates, and then the red line next to it shifts. And it's usually equal to about the size of the blast. The bigger the blast, the bigger the shift that follows on the plate boundary right after, if the volcano's next to the plate boundary. Anyway, all those blasts, plus all those 4s going all the way around the Cocos Plate and over to the east, over to Venezuela, add up. And then we look smack in the middle of it for the new break to take place. That's the cumulative total of everything around it, including the blasts. So if we have multiple blasts at Popo, and each blast is equal to a 5, and then we have a huge ring of 4s all the way around both plates, the middle is under stress. Jamaica. Going over the west to the, the Cayman Islands? The Cayman Islands? And Haiti again. So if you're in Jamaica, Cayman Islands, Cuba, Haiti, Dominican Republic, we have to warn the middle of this, which is Jamaica. But everybody on both sides for 200 miles to the east and 200 miles to the west, it's 400 miles across. We have to warn the center and the areas on both sides for the potential of an upper 5 to low 6. The cumulative total of everything all around you. Think of this like a giant pool full of water, and there's people splashing all around the outside edge, and you're in the middle, and you're going to get all those waves combined together at the center. Okay? United States, let's talk about this. Hawaii. So, Hawaii, what happened? I don't know what happened, quite frankly. I was looking for a 5 to hit in Hawaii. I think an upper 3 hit. I totally struck out in Hawaii, and I did not do another forecast afterwards. Have to figure out why I got it wrong. We might not be getting the full seismic picture coming out from the Hawaiian Island chain up the chain. I don't know. But I'm not using that as an excuse for my miss in Hawaii last week. Since then, a new spread of earthquakes has taken place all the way around the island. You can see it down to the southwest, up to the northwest, over to the east, and, of course, in the center of the screen. Center of the screen goes from Mauna Loa, across Kilauea, over to Pu'uo'o now. Pu'uo'o is the volcano on the east side or right side, and Mauna Loa is over on the left side, and Kilauea is in the middle. Pahalu's down along the coast, and it's a big ring of quakes. I think we're going to go the next step up from where we are now. That's just kind of a no-brainer on the next step up, which means we're going to go to 4s. If you're 2s and 3s now, you would go up to 4s. Look at the rest. 4s and a few 5s. 4s and a few 5s. Go over here to South America and Central America. What do we have? All 4s, and then those eruptions. And South America, look what we have. All 4s. Once we get beyond South America, we go back to 5s. But so it's 4s, 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 4s. I haven't even talked about Europe yet. So right now, we're at the 4 level, and that's good news. So if we're at 4 level going up into Kamchatka, it's 4 level coming back down into Hawaii. The spot that's going to be hit should be on the north side of Mauna Loa. If this was a giant triangle, we would just look at the center of it. No, I'm not being occult or anything like that. I'm just saying, if this is a giant circle, we look at the center of it, which is the big brown splotch, which is Mauna Loa. North side of Mauna Loa, new 4 due. I would also suggest, and you should do this, you should go check out 2 channels that cover Hawaii 24/7. And that's Doing Hawaii. This is on YouTube. I'll put links down below to their channel after the video uploads. But Doing Hawaii, they're great guy. And 2 Pineapples, great people. You guys go check them out. They cover this stuff nonstop, and they have other cool stuff on their channels too. So, definitely check. Live streams and that sort of thing. Now, let's go up into the continental United States, lower 48. We've already talked about the fires going on up here where there's no seismic being reported, right? And we've talked about the fires down here to the south where there's no seismic being reported. Wow. That's like, whoa. So what's going on here? Let's go up in the northwest and start looking at the small earthquakes. See what the deal is. Do we have any changes from where we were over the past few days? Well, the swarm at Yellowstone carries on and actually is picked up slightly. So the number of earthquakes, think of this like the beat of a drum. We've slightly increased the beat of the drum at Yellowstone, but you should be able to trace the rest of the earthquakes back up to the northwest. Those earthquakes follow the edge of the North American Craton, back up into Canada, where all the fires are taking place on the edge of the Craton, and down to Mexico, where all the fires are taking place on the edge of the Mexican Craton. The whole thing fires along the edge over the west, but we're talking about the deformed edge, the purple part that goes over to the orangish color or brownish color here, the stable Craton. Now that you've seen the Craton diagram and you know what it looks like, take a look at the rest of the quakes. Coming in from the northwest, it's following the accretionary belt, the green part, over to the purple part, and we're striking at volcano after volcano after volcano. I am not exaggerating either. We're going from Mount Rainier to Mount St. Helens, down to Mount Hood. We could go over to the west, and we go down below the boring lava field. The only earthquakes that are not directly related to volcanism or at a volcano are the ones going right north of Seattle. Now, I've got a warning going in Seattle for 2 more days for a 5.0 range earthquake to strike on the Seattle Fault in downtown Seattle. We're getting down to the last couple days of the warning. A new 3 has struck on the Strait of Juan de Fuca, just on the north side of the Seattle Fault. A new 3. But that's 100 times less power than I'm looking for. I'm looking for up to a 5. We have 2 more days to go. The reason I'm looking for a 5 there is just because we got 5s coming in down to the south a couple days ago, down at California. Right. Well, hold on, you can't even see it. Right there. So we got a 5 down to the south. I'm looking on the north side of the Juan de Fuca fracture zone on the fault interior to the plate. Energy coming in from the north, basically. It's coming in from the south, should be coming in from the north. We know it's coming in from the north through Canada. All the fires at the oil pumping operation, I heard they're trying to blame that on people now. It could be. I'm not going to rule out arson, but dude, come on. I guess they knew where to put it on the Craton, right? Like, you know, I guess they're the real fans of the Craton up in Canada. Oh, it's just common knowledge, the Craton Dutch. Yeah, right. Okay. So, volcano after volcano after volcano. Do I need to prove that to you? Because I know there's new people who just don't understand. When I'm talking about volcanoes getting earthquakes, it doesn't mean that they're going to erupt. Let's just, we've got to be clear about that because new people take it and run with it when I'm talking about earthquakes at volcanoes. It's that there's a wave which is traveling through the plate, and that wave seeks out the weak spots, the break points in the plate. Humans can drill in and create their own weak points, much like Mother Nature can punch up from down below and create natural weak points, where the magma chamber is down below and all the lava tubes and so cracks and faults that come up from there. And when these inflate and deflate, you tend to see seismic breakout around them. The volcanoes, I mean. So that's what's going on there. As we go down to the south, we go through Mount St. Helens, it's the same thing. We go into the boring lava field, and it's the same thing further to the south. Going over to the east, we're at the Washington-Oregon border region. That's a creative way to call it. Why don't they just call it what it is? A volcano. Let's go show you. Mount Hood. Let me get a sip of my coffee. Here we are. Stratovolcano, Mount Hood, Government Camp, Timberline Lodge, all that stuff right there. There's Government Camp, the town. Mount Hood, supervolcano. Oh, I'm sorry, stratovolcano. We'll be talking about supervolcanoes in a minute. Over to the east at Yellowstone with it breathing up and down and doing subsidence. They've announced that it subsided. Deflation occurred. It sank. I don't know how much. They said it was noticeable. A noticeable amount of deflation. Okay. Subsidence, as they call it. Wait, same thing. That's over at Yellowstone. Now you know why there's a swarm going on there. As it settles and rebreathes back up, you're going to get more breaking. And there'll be more swarming. It'll actually be way more. These are actual earthquakes, by the way, at Yellowstone. There's hundreds, if not thousands, of small tremors per day. And they get assigned magnitudes as well. But these are actual earthquakes. There's a difference between a tremor and an earthquake for eggheads out there who pay attention. As we go down here to the south, down through Oregon, what's going on out here? Oh, never mind. Oh. Hey, we can just brush this one off our shoulder like a piece of Earth's dandruff. This quake, head and shoulders. What's going on there at the quarry? Oh. Well, look, quarry might be a relative term that we're going to use for the rest of this update. So let me show you what we're right next to. See this? See Black Crater and Belknap Knoll? These are lava flows. Okay, here's Belknap Knoll. There's the lava flow for Belknap Knoll. You get the picture of what we're next to. 4-in-1 cone. 4-in-1 cones. Let's go take a look at this. Nice. Somebody told me that it was wrong to remove lava rock from national parks because if everybody on the earth took a rock, there would be no rocks left. And I said, that's a load of bull. That's a lie. Or maybe the people are just ignorant. The people who say that, they just are ignorant. They don't know. You know. They don't. Like, every person on the planet could go to Belknap Knoll and take a rock, a nice size one, and there'd still be plenty of rocks left just at Belknap Knoll. Yes, there are 7.5 billion nice size rocks just at Belknap Knoll. Yeah, there are. So, how do I know? Yeah, science. Science, guys. The way you know is you go in here real close like and you zoom in. And then you start counting the rocks just in this area. Then you get out your line measurement tool. You multiply it, you do a little trigonometry and algebra, and you figure out your square footage. That's how you figure out square footages, with algebra. Trigonometry. Oh, no wonder I could never compute square footage right. Always off by an inch. Just put up those baseboards, you'll never see it. What's going on along the coast? I wonder if these are explosions out here along the coast. Nah, this one's same size, but it's down in the plate. Okay, enough sarcasm. Let me tell you a true story here about something that actually happened 2 days ago. An earthquake struck at Newberry Crater. Anyway, let's go. I'm just... Any science buff is going to either be completely annoyed or get extreme entertainment out of all my updates. Maybe a little bit of both. Salmon River. You guys hear about this place before? I've heard about it. Topic of documentaries, actually. Is there anything else out here? How about those methane plumes? Or did they change to hot water now? There were methane plumes coming up off the coast out here. Then bursts of hot water. You know what's really interesting? Several years ago, over here on College of DuPage, I was looking at the shortwave infrared and looking at the fires out in Oregon, and I noticed black dots out in the ocean, and I made a video on it and showed everybody the heat signatures I was picking up out in the ocean. And a professor from the Pacific Northwest Seismic Network, along with a whole group of people that he's friends with online, came after me and said that it's impossible to see heat signatures in the water, and said that that was just an anomaly. Said it didn't mean anything. The heat signatures out in the water. Picked up on satellite. They wrote an article about it, going off on me, quoting the professor. It's Vice Media, Dutch Sense. And they call me an earthquake conspiracy theorist. But yet in their article, they've got this at the top of the article as they call me a conspiracy theorist. Weird, I don't ever talk about the Illuminati. Is that Naughty? Illuminati? Anyway, in here, they go off on me for a particular thing. Control F. We're going to search hot spots. So, here's the article going off of me, quoting the professor in many aspects. And they say that I'm the only one that can see them. That only I can see. So, here's the deal. We've got a problem with hiding things. We've got a problem with people who hide things, such as hotspots out in the ocean, and deny them. And now the professionals have come along and claimed that they found hotspots out in the ocean, and that it's a precursor to seismic activity, and they claim to have found it by accident while they were out there doing other seismic studies out here off the coast of Oregon. Interesting, because I recall telling the whole world about hotspots out here off the coast of Oregon, and everybody called me a conspiracy theorist and said it was not possible to have hotspots out in the ocean, that the ocean currents would wash away any heat, including that from lava and eruptions, that those couldn't even be detected, they said. All right, well, moving on. I'm a little bitter. Oh, maybe that's my coffee. Hold on. A little bitter about it. You see what happens, you young students here, all you Zoomers? Once you get to be a boomer, you get disgruntled, old and angry. Of all the injustice that's happened to you throughout your life, you start to bitch about it a little bit too much. Then what you do is you say something like this. Honey, fetch my laptop. I'm going on social media. All right. Should we carry on? Let's carry on. We haven't gone off the rails yet. Then we're just taking a little coffee break. I should probably take a smoke break. I don't encourage anybody to smoke. Still, I should probably take a smoke break. All right. Let's go down into California. Let's go look along the coast, see what's developed here. Okay, yesterday I did an update, but I didn't really cover it too hard. Going along the coast, along the creeping section of the San Andreas, the number of earthquakes has picked up. This is an increase in the number of quakes. Normally, we have a handful along the creeping section here next to Monterey Bay, and that's about it. We're normally not going all the way across the Bay Area, and we're normally not going all the way down here to Cholame, California. Instead, it's normally centered right here. So the whole creeping section, plus the areas on the north side and on the south side, is creeping. It's moving. I don't know how much. I don't know if it'd be measurable at the surface or not, but the earthquakes show us a trajectory, a diagonal line going from the big stack up at geysers. By the way, the big stack up here is at a volcano. I just hate having to show all this stuff every single update because my longtime viewers have seen this God knows how many times, thousands of times. But this big stack of earthquakes in Northern California is at this volcano here, Clear Lake, Mount Canacti. And on the side of it, humans have drilled in to get steam, to turn the turbines. And the turbines, they actually inject sewage into the ground here, guys. They take human sewage and pump it into the ground. They steam off the water and leave the nasties in the ground. Sooner or later, you're going to get an eruption of epic proportions. Hey, hold on. Maybe I have... They say that there's a turd problem on the streets of San Francisco. But have you considered that you're putting the turds down into the ground at the volcano to your north, and it may just be shooting them back out and landing on the ground, and it's not people really doing it like you think. It just falls out of the sky and lands in a pile on the ground because it's being shot out of the geysers to your north, where you're injecting in all those wonderful substances to steam off to turn the turbines. As we go over to Eastern California, let's get the heck out of there, right? So we have a stack of quakes going from the volcano, and then we have a line of quakes going all the way down to Cholame, California, down the creeping section of the San Andreas. I'd call that pretty much the whole San Andreas now, guys. It's the whole thing. There's only a few spots in between that need to be filled in for there to be a perfect line going from all the way north to all the way south. Now, whenever this happens, whenever all of California starts to shift along the coast, we tend to see significant earthquake activity accompany that on land, like compensation sort of. So first you get a bunch of small movement, then you see a new big quake break right in the middle of all of it. That's usually what happens. What's going on along the border? Well, the number of earthquakes up here to the north has dropped off, but we're still at what I consider to be the caldera of a supervolcano itself, and it is a supervolcano caldera up in Northern California between Lake Tahoe and Pyramid Lake, right here. This ancient supervolcano caldera is lined with its own volcanoes, geothermal fields on both sides, two folded basins on either side filled with water, Lake Tahoe and Pyramid Lake, and again, it's a giant supervolcano. Now, we get fires and earthquakes that break out around this thing, usually on the west side, but sometimes right down in the center of it. In this case, the earthquakes are all around it. South side, down by Steamboat Springs geothermal field. North side, just west of the Needles at Pyramid Lake geothermal feature. And I don't know what's all the way over here, but I want to go see. I'm pretty sure there's a volcano there, but I don't know for sure. So let's go take a quick gander. Gander means look in hillbilly Missouri here. So Lake Almanor is on the base of Lassen Stratovolcano. I keep doing that. What is going on with the supervolcano thing? I've got supervolcanoes on my mind. I never misspeak like that. I keep saying supervolcano. What the heck? Tripping. All right, let's try this over again. We're live, right? Bill O'Reilly. Thing sucks. I'm not reading anything though, so yeah, I guess that's the problem. Lassen Stratovolcano, and on the side a huge volcanic field. Lake Almanor is at the base of it, and the closest volcano we either have Swain or Mount Harkness and Bonte Peak or Black Cinder. Which one is the closest? It looks like there might even be a few more down to the south that are not marked. Down here? But this could be old lava flow, not butte. I don't know. That looks like old tuftage. Anyway, all right. Anyway, we're a matter of like 3 miles. Okay? So these two at the base of another volcanic field, these two around the supervolcano. As we go down to the south, this stack of earthquakes here right along the border, I'm going to pull the 3 in the middle. This brings us out next to another volcano, east of Big Pine Volcanic Field. Big Pine Volcanic Field should tell you the name of what's there, a volcanic field. USGS doesn't list it as that, though. They just list it as Big Pine. Here's Big Pine Volcanic Field. Here. And it's littered with volcanoes. So, Crater Mountain. Some of these are so old, they go back up into the foothills themselves. They don't even have names associated with them. And then some of them come out. Taboose Creek Volcanic Cones, plural. Okay. Now, over here on the east side, we have Yuba Hibi craters. They're parallel to each other on both sides of the volcanic range. In the middle, look what this is. Seriously, now, I'm not kidding. In the middle, it's another volcanic field that's unmarked, unnamed. These are all old volcanoes. This is right here. All of them. That. Those are 3 fissures right next to each other. There's another one there, another one here. These are ancient volcanoes right here. I'm showing you a unmarked, unnamed volcanic field. This is not named, undiscovered. Nobody's realized that there's a bunch of volcanoes right here, apparently. Otherwise, they'd have it marked as a volcanic field. In between Yuba Hibi craters and Big Pine Volcanic Field. And you can literally see the remnants of the old cones that are out here. Okie dokie. And the earthquake's right next to it. Now, there's others. We spread up to the north, and we have more. More ancient, again, unnamed. There's just no name on this. Let me turn on my borders, labels, and places just to make sure. Because I already have the Smithsonian place marks all turned on. Yeah. Yeah, no volcanic name on there. I mean, don't do this, but if you were to go plant your flag on it and name it, I guess you could. It probably already has a mountain name, but you could go up and be like, look, there's an ancient volcano. Look at this. Here's the rock to prove it. Boom, flag. I get to name it. But they would probably already call it Mount whatever mountain it already is. But when you do discover big things, you do get to name them. So, okay, down to the east by southeast we go. We leave the swarm location. The swarm location's a volcanic location. Come on. Just like all the others coming down the coast. Why are the volcanoes getting hit? There's a wave coming down the coast. The wave is a seismic wave, and it's going to wherever it can seek out to release, whether it's a drill point, whether it's Mother Nature's punch points at volcanoes. Look at Thirsty Butte and Unnamed Volcanic Butte. Let's go see what this one is. Ooh, that's interesting. What the heck? Oh, that's really weird. That's really weird. Okay, this is on the side of our nuke test sites. These are all actual nuke test sites. Let me turn on our Google Earth community here. Just get a name on one of these. U.S. nuke Operation Delamar. This is April 18th, 1987. 150 kilotons. We also look at U.S. nuke Operation Darwin. June 25th, 1986. 22 150 kilotons. All right, that's just one little section of this. Our nuke test sites go up, around, and back down through all of this. All of these are underground nuke test sites. It's not an aerial bombing range. They plant nukes in the ground and detonate them. Man-made faults are what is the cause or of the reason for the wave to seek out this location in particular. Just like the volcanoes are seeking out, the wave is seeking out the volcanoes, the wave is seeking out the weak points in the plate as it passes through one area to the next. That's what's going on along the coast. Let's go down along the coast. We go down here to Kolami, and we go back down and across over into the valley. Once we go into the south tip of the valley, guess what's down here at the south tip of the valley? I won't make you guess. You have a choice. It's between volcano and or human drill point. What do you think is there? South tip of the valley. Well, if you guess drill point, you're right. The drill points go through the farmer fields right here. And let me just zoom in and show you. We've got oil and gas out here for the most part. And that's not for water, even though they are collecting water there. Let me show you. It goes right out into the desert. Here's another example. And we go around the south tip of the valley, down through here where it says Wheeler Ridge. All of these are oil wells. And we come back up and we go up through the farmers' fields again, out of the desert, right across, and just keep on going. Okay. And we go up around the valley, up this side. Let me show you. Like a giant letter J. And up here at the tip of the letter J are 100,000 more wells. Okay. Our earthquakes are going right along that edge. Going down off the San Andreas, down to the south tip of the valley, meeting up with the drill points. It's indisputable. That's where the quakes are going in the valley, down to the south. Once we get out of the valley, though, we go down along to the coast. We've now jumped down to Carpinteria, California. Wait till you see what's here. Wait until you see what's here, guys. Another one, just like the other one. But what's the other one? Well, there's Carpinteria. But do you see where I have these marked? See where it says Ojai and oil? You see that? Ojai, California is where we start with our oil pumping operations again. And I just have them roughly marked here because they're all throughout the hillsides. They're actually kind of hard to find. So you have to really kind of zoom in on these back of the hillsides, and you differentiate between a grow operation and an oil well. In some parts, you'll get the oil wells right next to 99 green plants. Ah, yes. Yeah, getting the oil extraction out of it. It's to extract oil, Dutch. What kind? Okay. Let's go. I did get off the rails a little bit in this update, but we're okay. We're staying steady. It's like a slightly rough seas today, but I'm managing to keep the ship upright. Once we go out here into the Mojave Desert, I'd like to bring you all the way out into the central Mojave, central southern Mojave, out to a place called Ludlow, California, and show you this lone earthquake out here in the middle of the desert. Tell you a story along the way as I got my first real trouble event back in 2011 with the mainstream media and the professionals. Back in 2011, a radar signature showed up coming out of the middle of July in the middle of the day. Not a cloud in the sky, no precipitation, but on radar coming from the ground, moisture coming out of the desert from the ground level. And I zoomed in on the area on the radar, and I was like, wow, okay, that's out in the desert. And then I went and looked at visible satellite, and I saw there wasn't a cloud in the sky. Completely clear. So it couldn't have been rain. And then I went on Google Earth and looked it up. Oh, I saw these black things on the satellite. I thought, what are those? Are those lakes or something? And I went on Google Earth and zoomed in and saw they aren't lakes. Those are volcanoes. So I made a video and showed everybody the moisture return coming out of the desert. And it was blowing, and it was so big, it was miles wide. And it blew up, and it went down over L.A. and vaporized off by the time it got to L.A. It was that big of a moisture return showing. But again, nothing visible to the human eye. You're looking from above, you don't see anything. Even though it's completely clear. Again, not even a cloud in the sky in the middle of the desert in July. So I make my video, show the moisture return, and within the day, the USGS responds to my video. And I'm a young channel on YouTube with a few thousand subscribers, and they come in to steamroll me over and try and get me to take the video down. Said it's a mistake and that I'm mistaken. And all I said was that it was some kind of thing. All I said was that it was moisture showing up coming from a ground level next to these volcanoes. This is me saying this. Next to the volcanoes, moisture return coming up. They said I was mistaken and that it must be a thunderstorm. In their article, their press release about my video, denying that there was anything going on there. They said there's nothing at the location. This is their press release basically said nothing at the location and that I must be mistaken. It must be a thunderstorm. Well, guess what? It went on for 3 days straight, night and day. And by day 2, they deleted their press release about me from the California Volcano Observatory, the CVO. Deleted their press release about me, denying that there was anything going on there. Now, it's weird because their press release said there was nothing at the location, right? Well, there's 2 volcanoes. That could be chance or coincidence, I suppose, with the steam coming out of the ground, right? It wasn't a geyser, though. It would be over miles. However big this thing was miles wide. The moisture being released would have been coming out of the mountains themselves. This is the location of the biggest earthquake in California's recorded history. The Hector Mine earthquake from 1999. Now hold up, because they said there was nothing at the location at all ever, and said further that it didn't mean anything, and then it turns out the biggest earthquake in California's history, recorded history, struck here in 99. The Hector Mine quake struck right here. So, now we're getting microquakes there. Not a big deal. The reason I'm telling you the story is because I got so much trouble and everybody went off on me so hard over that plume thing from Pisgah Crater, next to Pisgah Crater. So what could release a plume out of the ground, causing heat signatures? How about the plate shifting and magma down below? And anybody who would deny that is either just an ignoramus, Or, I don't know, man, like, to deny that the plate could shift and release heat at volcanoes is kind of stupid. Like, you'd expect that, and if it didn't happen, you would think there was something wrong. But the public gets all panicked when you start talking about volcanoes and heat releases, so better deny it. Anyway, when I start seeing stuff like what I've seen over the past few days happening out in California with the eruptions of moisture, and now fires going along areas where there were no storms. There were no storms across there. You can't tell me that the storms blew up and caused lightning strikes when it's clear and they happen on a nice clear day like today. And the spacing on that says craton shifting. That matches with this. The fires. Down through Mexico, up through Arizona, the deformed edge, up through Oregon, and up through Canada. It's a perfect match for the fires. To ignore it's just insane. So I'm not ignoring it, and I won't let anybody pressure me into ignoring it or deny it to my face, because, man, you're freaking denying, whatever. Not here to call anybody any names. Except for myself. Idiot savant. Quake Man. The Rain Man of Quakes, you know. Let's go down to the south and take a look and wrap this up. We're going through Southern California on the San Jacinto Fault. San Jacinto. We trail off with earthquakes down to the south, right down at the south tip of Salton Sea, going right down to the border on both sides at San Diego, and over to the east, right down next to the solar farms. So we go down to the tip of Salton Sea, and then down to the solar farms, and down to, I don't know what's over in San Diego, actually. Hold on. It's a quarry blast. As opposed to an explosion, I guess it's good, right? Said we were going to be talking about quarry blast more. Well, how about the difference between an explosion and a quarry blast? Let's go down to San Diego, take a look at this quarry. What are they quarrying? Usually when they're doing big quarries in spots like this, it's because of like a star fort or something. They're with all the, okay, I'm just going to tell you right now, with the amount of baseball diamonds and tracks and all the, there's occult mathematical and energy uses for these shapes. I'm not getting weird on you. I'm just telling you for real, man. Like, so they'll put a lot of these. Here, hold on. Before you think I'm tripping, I'm going to take you over here to St. Louis, Missouri, where I found out about this. We're going over around the famous Cahokia Indian mounds over here in St. Louis. They're the biggest mounds in North America. Here's the Cahokia Mounds State Park. Mound 72, right? I mean, now look what's on one side. You see that? You see that? It's a horse racing track. It's the only one in the Midwest here. The only horse racing track that's, well known. And then on the other side, we have this velodrome thing, or the technology raceway for cars. And again, it's one of the only ones in the Midwest. On either side of these. Okay. Now, I started finding this all over the world. Go over to the Great Pyramids. They'll build it, and sometimes it's a golf course too. And they've done it with the golf course right here, by the way. So they'll do a golf course, they'll do the sports arenas, they'll do the ring things and stuff around these ancient megalithic monuments for some reason. And I think it's to have to do with the shapes being antennas. But anyway. The shapes being antennas that capture energy and transmit it somewhere, where someone sits there and collects that. So let's go back over here. Over here to San Diego. And here we've got our core. And wait. The other thing that surrounds the Cahokia Mounds. Wait, there's more. The other thing that surrounds Cahokia Mounds are the quarries. And I mean massive. So, again, it's not up for debate. You can see them, right? Okay. So now that you've seen that, you got the quarries, you've got the sports parks, you've got the racetracks, and the tracks laid out around it. Now you get over here, and you got your quarries, you got da-da-da-da-da. It's the same thing. The only thing missing would be giant Indian mounds here. So, just saying. Oh, Castle Park, huh? Is that what this place is called? Castle Park. You got to be kidding me. What do you want to bet there's some ancient castle that was here that they tore down? Right? Or ancient, right? Whatever you want to call it. An old 1800s castle that got torn down here. Well, I bet you. It's just a guess. Man, we did go off the... I've been trying to go off the rails this whole update. Literally like a train trying to pull itself off the tracks. Finally did it. Right at the end. Now let's carry on over to the east because we're not at the end yet. We're going to go over to Colorado. We're going to go to Texas. We're going to go to Kansas. We're going to go over to the East Coast. So our adventure is not over quite yet. Southern Colorado, North New Mexico we go. Western Colorado is where we are triangulated from. We're going to be looking at nothing but drill points across Colorado, Oklahoma, Kansas, and so forth over to the east. Once we get to the New Madrid, we'll stop looking at drill points. These are all drill points that I'm getting ready to show you. So, for instance, earthquake epicenter, right next to it, drill point. We're at the Colorado-New Mexico border. That's what all these little pads are on the ground here. And they just go on and on for miles. Every one of those little spots in the ground is a different drill point. This is Colorado here. This is New Mexico south of this line. And it carries on right across over into New Mexico with more oil and gas wells. So, drill point there. Southern Colorado, edge of the Craton, drill point. Texas, West Texas, drill points. Let's go show you. Toyah, Texas. Toyah, Texas. We're going down to more drill points on the edge of the Craton. Are you surprised to find out that the wave follows and seeks out these spots? If they weren't here, the wave would go over to the New Madrid and build up there and reflect back into itself, and we get big earthquakes on the New Madrid seismic zone. So, I mean, should we be thanking these people for directing the wave along the edge of the Craton more than it already did? By drilling this much? It doesn't expend the wave, but it sure guides it. Down here to the south, here we are, Texas, drill points. They just lay the pipelines out on the ground. It's easier to do that than to bury them. And if there's any breaks or anything, they're able to go drive along and inspect them pretty easy. So yeah, they just lay that stuff out on the ground. All right, that's Texas. Southeast Texas, 2.8 near 3.0 earthquake. We are at Three Rivers, Texas. So I'm not normally in Southeast Texas. It's only when the edge of the Craton is moving. The Craton. We talk about the Craton a lot. Look one more time. Look at Texas, Southeast Texas. And then look at the quake, Southeast Texas. Wow. It's a match. My biggest discovery. But guess what? Over here on the edge of the Craton, look what we have. See all these? What are those? Drill points again and again and again. And you see how many there. Those aren't houses. Every one of these white pads is a different drill point. With lots going on at each one. Now we go on and on and on, and you get an idea for how many different drill points they got going on here. It's kind of ridiculous. Okay, enough of that. Up to Oklahoma we go. So should I just pull the biggest of the bunch in Oklahoma? I guess I will. We'll just pull the near 2.0 level activity in central Oklahoma. Cole, Oklahoma. I haven't had to show Oklahoma in a while. It started swarming this week. I'll take a swarm anytime over a 4. And in Texas, you got an upper 3 to 4.0 earthquake instead of a 5. You got a 3.9 in swarm. And that's good. Oklahoma, 500,000 or more different drill points placed out across the area. Here's one example right here. A set of tanks and pumps and jacks, and then a condensing, compressed pipeline station there. But the drill points are all over the place. They're just like down in Texas. They're a little harder to see, but once you know what to look for, you can't miss them. All right, that's Oklahoma. Now, Kansas. The biggest earthquake in the Midwest struck up in northwest Kansas, Alton, Kansas. And I don't think we have any marked drill points here. We have to go back to the 1950s and the 1960s for the drill points that exist at this spot. Now, to see them, I don't know if they'll still have active functional wells here. They might not. The only way I know about this is I had to look up the Kansas oil well history whatever site. Hold on. Yeah, we still got one out there. Okay, we got a well here, so I don't have to go and try and prove it to you. We have an active functional well here in our imagery date as of 2022. So at least one, okay? Now, there'll usually be like one or two left over on a giant old oil pumping operation like this. It still produces. Even though it's a little bit, they'll still try and get it out. Now, I don't know how many there are. Look, there's even more. 1, 2, 3. Let's go down the road to the jack. Yeah. All right. All right, nice size oil pumping operation here. It's not just leftover remnants. We got at least 1, 2, 3, 4, 5 right in that field. So, yeah. Biggest of the bunch, Kansas now, oil. Now let's recap. Colorado, oil, gas. Texas, oil, gas. Texas, oil, gas. Oklahoma, all oil and gas. And oil and gas. I just proved it to you. So if you were skeptical about drill points leading to earthquakes and edge of the craton being a facilitating factor for that, I just proved to you all those quakes are, well, the ones in Oklahoma, you can look up the rest, but come on. Once we get over to the east, we're in the New Madrid seismic zone and on the eastern edge of the craton. We strictly go from drill points and volcanoes to what I would consider to be fault zone movement. Regular earthquakes, so to speak. A wave passing through a broken area in the plate, and it just hits a broken area in the plate. A fault. And that's what we're getting over to the east. Whereas over to the west, drill point, drill point, drill point, drill point, drill point, along the craton where there would be faulting that would take place if they hadn't drilled. Crazy, right? Hey, by the way, when I found all this, when I discovered earthquakes happening at oil and gas wells in 2010, every professional in the world called me a tree-hugging conspiracy theorist and said that fracking earthquakes were extremely rare and minor. And they furthermore said oil pumping operations don't get earthquakes of any significant size. That was said to me, and it's still in comment form down below in my videos from 2011. If you want to go back and have an entertaining read, go back to my videos from 2011 and read the comments having to do with the denial of the earthquakes striking at the pumping operations in Arkansas at the time. Okay, final point on this. We'll go out of the New Madrid seismic zone where the wave now goes around and up the east coast. In the past, the wave would have gone through all of this, reached the New Madrid, and reflected into itself at the N-shape bend in the plate and break here with big earthquake activity. Now that the perforations have taken place, it guides it right down to the south, and that tends to keep it to the south. Goes around the south edge of the craton and back up the east coast. I don't know if the human pumping operations are doing that or if that just is the way it's always been done by Mother Nature. Either way, it goes up the east coast and we tend to see natural earthquakes along the edge of the craton. Go over to Virginia and we can go, oh, I'm sorry, did I say Virginia? North Carolina, sorry guys. We're at the Virginia-North Carolina border region. There'll be people in North Carolina like, don't you dare lump me in with them. It's not neighborly. Hey, look, is this some kind of quarry blast? No, it's at a 1.1 kilometer depth. Well, that's odd. We got a giant quarry right next to it. What's going on there? Electrical generation. What's going on here? Wait a second there. What do we have going on here? We got a quarry with lakes right next to it with a pumping operation of some kind. I don't know if that's to pump water. I don't know of any drill points over here that, again, we shouldn't have any oil and gas drill points here at all. Wasn't expecting to see that. The Glamping Collective. Really? Oh, wait, look what's going right through here. Oh, man, how could I miss it? High voltage power lines going through the mountains themselves. Look at that. Right down across, down to the generator itself, where they're generating at the power there. Okay, wow. Wow, they're actually moving that power out. Look how far they're taking it. Wow. That's connecting with the greater trunk. That trunk must be going down to the south. Look at this. Yep, hydroelectric dam. It's coming from a hydroelectric dam and going straight to the south along the transmission lines. Think of it like this. A very low frequency wave is coming up from down below at the hydroelectric dam and following the power lines down below in the plate, and we get an earthquake along the way as the wave spreads. Now that's going up to the north. Wow. High voltage power line earthquake over on the East Coast. USGS isn't going to tell you about that, will they? Oh, it's just chance and coincidence. It's just chance and coincidence. Uh-huh. Whatever you say, Mr. Belvedere. All right, Jeevesy. All right, let's get out of here. You guys ready to wrap it up? Do you have an earthquake plan? You know, I try to keep it positive. Sometimes I get way down. Serious. It's real easy to get down these days, guys. Don't let that happen. Anyway, trying to keep it positive. Spread of 6s going out across the plates, shifting the area from Japan to Alaska. I suppose that's good news for the people in Japan. It's bad news for me and my forecast. I was looking for a 7 to hit in Japan. That warning time has come and gone. So Japan looks like it's out of the mix, but I've been wrong before. I mean, there's been times where I cancel the warning and then the earthquake hits. But it was a full 14 days that we watched. And all that took place, I was looking for a 7 and a 6.5 hit. In the middle of Japan, when I'm looking on the north side of Japan, I was looking up here for a 7 and instead a 6.5 hit here. That's it. That's all that took place in Japan for the most part. Then down to the south, out in the islands, out in the ocean. Of course, we got a 6 down there, but that's not that big of a deal. So, is it a hit? Is it a miss? I consider it a miss because I'm trying to get it down to 200 miles and within a magnitude. And this is far outside of 200 miles. So if I'm looking up here for a 7 and a 6.5 hits all the way down here, that's most likely not the earthquake we're looking for on the north. So what happened? Well, I'm trying to figure out where the energy went. The only place I can see that it's still going and gone and being absorbed is Alaska. Where else is it going to go? Every other spot is broken. Either that or the energy completely vaporized and disappeared. And we all know that happens every day, right? Oh yeah, energy just vaporizes and disappears. Actually, energy never does. It'll transfer and transform, but never just goes away. Like, there is no energy just goes away thing. If it's dissipated and absorbed into something, then that's where it went, right? It gets dissipated and absorbed into something. It doesn't just go away. And if you absorb enough something into something, guess what? It gets saturated. And when something gets saturated with something, it gets overloaded with something. And you can saturate something with a wave, and that wave will break whatever you saturate physically. Okay. One final point. Earthquake plan. Time for you to dust it off. Be prepared. This is go time internationally. I did not cover the Mideast or Europe. I'm not going to in this update. I have to turn on the European feed, and I'm not using the European feed right now. People have been getting my IP address apparently from European feed. I don't know. A hacker wrote me, told me that they're getting my IP from the European feeds, and they're bombing me from Europe. That's what they told me. I don't know if it's true. But I'll tell you this, I mean, I have stopped using their feed, and I have noticed that my stream is staying on a little bit more. I don't know if that's directly related or not. It might not be. It might just be coincidence on that. All right. Why would anybody want to shut it down? Who cares, right? Like, I'm just a person. I keep telling you to have an earthquake plan. People ask me what my earthquake plan is. Well, if I'm asleep, I'm going to wake up and freak out. I'm going to wake up. It'll be the first earthquake I've ever felt. I've never felt an earthquake. First earthquake I've ever felt, so I'll be freaking out. I'll be putting on my shoes that I have on the side of my bed. I'll be putting shoes on in case there's something broken across the floor and in case the power's out. Might be dark, might be night. It's dark in the house and there's broken things across the floor. Second thing I'll probably be doing is immediately checking on my wife, make sure she's okay, and collecting the cats and putting them into a room that doesn't have broken things across the floor. So, or into an actual, trying to go get the cat's bin, their little cage, and put the cats into the cage so that they're not running around on broken glass floors. Right? Because your pets are going to be scurrying around and there's going to be glass on the floor. Okay, we're going to have another problem to deal with that's even worse, right? So I'll be first making sure that the wife's okay, verbally, and then immediately collecting a cat by the back of its neck, most likely, because it'll be freaking, and putting it into a safe spot. And then third, I will be possibly taking shelter. Possibly. Or taking shelter along the way as trying to collect the cat around the time the earthquake's actually all happening. All at the same time, I'm trying to do all three, probably. I don't know. By the time I got my shoes on, the earthquake's probably going to be over. So I'll be then trying to collect the cats that are already running around. And at some point in there, I'll remember I've got an emergency kit with a bunch of shit in it that I may or may not use, but I'll be thankful that I have it. And that's probably what you should do. The emergency kit thing. You should probably be a little bit more prepared than I am, though, when it comes to the earthquake plan. So maybe you might want to actually run through it with your roommates or your family. Might want to think it through just a little bit more than I have. And then also you might want to check your elevation, and you would do that on Google. You would go check to see what elevation your house is at if you're ever worried about a tsunami. So if you're worried about tsunamis, you would actually need to have an additional factor in this, which is you need to know what elevation your house is compared to the ocean. So that way, if a big wave is coming your way, you know where to go ahead of time, or if you even need to go at all. Right? You're 100 feet above sea level, and a 50-foot wave's coming in, okay, you're going to be okay. But if you're at 100 foot above sea level and 100-foot waves coming in, well, you're going to be dealing with some water. And everybody below you is either going to be screwed or they're going to be coming your way. So, and you might want to go higher. You might want to pre-pick a hilltop that you already know how to get to. That's not going to be blocked off with traffic from all the normies driving around who don't know where they're going to go. That you know where you're going to go ahead of time in relation to a tsunami because you've already been on Google Earth, you've measured your elevation, you've measured your hilltops around you to see how high they go, and if there's a little gravel road or something that goes up to them, if you have to run up it, so be it, you'll be on foot, or maybe you'll be able to drive your car up there if the wave is big. So, things go into planning. There's actual planning that goes into having a plan. Do it. If you live along the coast, do it. With the tsunami thing, you'll need to go download a copy of Google Earth. It's free. earth.google.com. And then you can see what your elevation is. It's real easy. I mean, there's other elevation checkers, but how are you going to check the hill or down the road from you or something? You have to know the location of it. So just go on Google, move your mouse around, and you'll see what the elevations are, and you'll be able to pick a hilltop nearby your house that you can go to while everybody else is driving around, scrambling, trying to figure out where to go. You might even serve as an example for other people. They might be like, oh, look at that person. They're going up there. That's a good idea. I'm going to follow them. And that's for the worry on a big tsunami. That only happens once every 10 to 20 years. Okay. I don't have anything else for you guys. Please be prepared. Don't be scared. Much love. Let's end this on a good positive note. It's not all. Last time I said, did I have any positive news for you? And I said no. Well, I've got good news for you. There's good news for you guys. The good news is it's almost summertime here in the Northern Hemisphere. It's getting warm outside. You can finally get some vitamin D and start to recover from all your interior computer moments. all those down moments that you have while you're sitting there reading all that bad news that's pumped into you by AI to continue clicking and getting you to sit there all day long and get pale and gaunt and lack of basic necessities as you let your bodies dilapidate sitting in that computer chair. Okay. All right. I said I was going to be positive. I got a cup of coffee here, It's hard to stay positive, isn't it, guys? It is. You got World War III on the doorstep. I'm like, I'm staying positive. You guys are like, Dutch. It's not World War III, by the way. Not yet. Every day that we aren't at World War III should be another day that you celebrate as a good day. 9:01 p.m. Perfect time for me to sign off. Peace